Welcome to the video solution for problem 8 from Superquiz 1. In this video, we're going to be finding the tangent plane to a function at a specific point. Now, one thing that seemed to cause people a lot of consternation during the exam itself, it's actually something we talked about in class. There's something that looks a little bit different here, that I seem to have given you a third coordinate, right? So if I do this, what am I, like, why am I being nice here?
Wait, didn't you just give us like the f of AB?
I sure did, right? Like, what is this? How would you get this 13 if I had not put it in there, right? If I had hidden this thing, right? I hide it behind a wall or something, right?
You have to plug it in.
Yeah, if you did this, exactly, right? If you'd have done 3 times -2 squared plus 1 squared, right? Which is, I'm just plugging it into the formula. What do I get? 3 times 4 is 12 plus 1 is 13. The point I gave you had 3 coordinates in it. Now, this, of course, would be an x, y, z coordinate. You say, but this is a function of just 2 variables. Okay, so if that's your x and that's your y, what could this -4 possibly mean? Well, of course, this is f of x comma y, right? In this case, if you put 1 in for x and -2 in for y, you will get out -4. I was actually giving you a little bit of help. You didn't actually have to compute f of 1, -2, because I gave you the -4. All right, well, how are we going to find this tangent plane? Well, we know that the tangent plane has what we call the point-slope-slope form. So you can write down z equals, and you're going to need f at the point 1, -2, which we actually know will be -4, plus, now we need the slopes. So we're going to have the partial derivative in the x direction at 1, -2, times x minus 1, where the 1 is coming from here. And then your other slope, the partial in the y direction at 1, -2, times y minus -2. So this is the equation for the tangent plane. Now, we're not done, of course, because we haven't computed all of these different values. Well, the first one, like I said, I gave that to you. So this is going to be -4. But we actually need to compute some partial derivatives. Okay, not too bad. A partial derivative with respect to x. So we treat the y as a constant, and we're going to get 6x times y. And then here again, we're treating y as a constant, so we'll just get minus y, because the derivative of x is 1. Okay, and so if I want fx at 1, -2, then I plug x equals 1 in and y equals -2 in. I will get, let's see, 6 times 1 times -2 minus -2. This is -12. This is going to be plus 2. And so -12 plus 2 is -10. All right, so that's what this piece is going to be, -10. And then I need to do, of course, my fy as well. The partial with respect to y, let's see, I treat x as a constant, so I just keep the 3x squared. The derivative of y is 1, so 3x squared. And again, derivative of y is 1, so I just get minus x. And so fy at 1, -2, well, I don't even have to worry about the y value anymore. I just plug x equals 1 in. I'll get 3 times 1 squared minus 1. Okay, this is 3 minus 1, or 2. Okay, and so I can simplify this now as -4 minus 10 times x minus 1 plus 2 times y. Well, we might as well make it plus 2. There is the equation of our tangent plane.